Hey everyone, this is Paul Finley, and I'm really excited about the topic that we had for this week. And it's always fun to do a little bit of what ifs and what could have beens when it pertains to history. And I've actually chosen the Transistor and just what could have been if they would have actually pursued something different. So I'm going to give the brief history first, and then I will get into my alternate history. And here's my presentation. Thanks. The transistor is pivotal in how our world works today. For over 67 years, the benefits of this invention can be seen in virtually every electronic device since it was created. But it was the technology right before this that led to the invention. The vacuum tube moved the electronic age forward with its invention in 1907. With its ability to amplify telephone connections and radio signals, it had become the mainstay in the manufacture of electronic goods. The mechanism itself was weak, unreliable, and required constant maintenance, so new ways of making the technology better were constantly in the works. The theory of surrounding a semiconductor with an electric field to amplify the incoming current had been around since 1925, but the science behind making that work was still years away. It wasn't until December of 1947 that scientists Walter Brattain, William Shockley, and John Bardeen would have the resources to push through to the next step, creating the point contact transistor. In March of 1946, Bardeen, in his work with semiconductors, discovered that electrons were getting stuck in the silicon that he was working with, and concluded that in order to get the results they were looking for, something had to change within the compound of the silicon. A breakthrough occurred in November of 1947. By adding distilled water or acetone to the silicone he was working with, Brattain noticed that the electrolytes in the liquid changed the properties of the surface, and by shining light on the newly treated exterior, he received a larger current than without the liquid there. 5 days later, both men were able to create a 10% increase in output by pushing a tungsten wire through a drop of water and then touching it to the silicone. By doing so, they showed that they could pull the electrons to the surface, but it was not strong enough. So during the next few weeks, they tried different configurations. It wasn't until December 16th, when they combined two gold foil contacts sitting on germanium crystal, that they produced a result that was almost 100% improvement in output. Shockley came into the picture after the initial discovery and was upset that he was not a part of the process, so he took the findings, and in the next few weeks he added a more refined process that allowed for an easier way of manufacturing that led to the design that we associate with today. Since then, the transistor has been in a constant state of growing smaller in size while growing more prevalent in its uses. A good example of this is its use in the microprocessor. The original Intel 4004 chip had 2300 transistors, and in comparison, the last generation processor had 1.4 billion. Companies now have transistors that are only nanometers in size, and the industry produces more than $1 trillion annually worldwide, ranging from space travel all the way down to electronic toys for our children. Okay, in this alternate history, scientists continue development of the solid state drive, but also work on improving the vacuum design. By 1954, the vacuum tube is reduced by half and is 5 times as efficient. By experimenting with different gases, scientists find out that they can do away with a pure vacuum system, and because of its characteristics, helium becomes the gas of choice. By 1960, the size of the vacuum is reduced to that of a quarter. At this time, it is discovered that the vacuum style is faster than the solid state, but still is larger. After Kennedy's space speech in 1962, extra government funding comes in for both designs. After heat and radiation stress tests, it is found that the vacuum design is more space-worthy, while showing that precision instruments are more accurate. This leads to lighter instruments and better protection for cockpit and crew. By 1972, processing speeds of vacuum chips are 3 times faster than that of the solid state. This causes them to become the standard for chips moving forward and leads to the solid state becoming diminished. By 1982, processing speeds exceed 18 megahertz, and by 1995 they jump up to just under 600 megahertz. In 2012, a new prototype chip only 150 nanometers in size is created, with a processing speed of 0.46 terahertz. This in turn is 10 times the speed of our chips today. Okay, as my references are cycling through, just wanted to say thank you for this project. It was fun to allow my mind to change things up a little bit and to contemplate on what might have been. And it was definitely a great project. Had a lot of fun with it. Hopefully it came out okay. And yeah, thank you for your time.